Today is Section 8, Part 1, and we're going to be talking about inverse relations today that will lead up to us talking about inverse functions. Okay? The definition of an inverse relation, we have two relations are inverse relations if and only if whenever one relation contains the element AB, the other contains BA. Okay? So we're just going to jump right into an example because I think this example will explain it. This should be very easy, okay, and hopefully you'll see why in a second. Alright, so we're going to find and graph the inverse of the relation 2, 1, 5, 1, and 2, negative 4. You can see over here, I've already graphed 2, 1, 5, 1, and 2, negative 4 on this side. Okay, so this definition says if this contains the element AB, then the other must contain BA. So my inverse if this is AB, my inverse has to be BA. Here, if this is AB, my inverse has to be BA. And here, if this is AB, my inverse has to be BA. Notice what happened? X's and Y's just flip spots. Yes, it is just that easy. We just flip, flip, flip. Okay? So we come over here, we have 1 on our X, up 2 on our Y, 1 on our X, up 5 on our Y, negative 4 on our X, and up 2 on our Y. Okay, now if you look here, we see the before and after. This is the original, this is the inverse. Okay, this is something very unique that only happens with inverse functions, is that it's reflected over this line. Do you know what this line is? This is the line y equals x. Okay, which makes sense because when you're going from here to here, you're just switching the values of your x and y. So you're reflecting it over the point of where they would be equal. Okay, so this is 2, 1. And then if you flip those, this is 1, 2. And so on. Okay, so we reflect over this y equals x. So, inverse, write this down. Inverse functions and relations are reflections across, one C, 2 S's, across the line y equals x. Okay? Should remember that. It'll be very important. Okay, another example and then we'll be done. Alright, given 63061310. Find the inverse of this relation and graph all points. Okay, let's start off by graphing these points. So I have 6, 3, 0, 6, 1, 3, and, oops, wait. I messed up the example. This is supposed to be 6, 0, my bad. Okay, so, and rewind. We have 6, 3, 6, 0, 1, 3, and 1, 0. Okay, we are making this very nice rectangle. Okay, now our job is to find the inverse and graph it. What are we expecting it to do? We are expecting it to reflect itself across this y-axis, so it should probably be standing up on its side. Okay, so my inverse, if this one has 6, 3, that means my inverse has to have 3, 6. If this one has 6, 0, that means my inverse has to have 0, 6. If this one has 1, 3, that means my inverse has to have 3, 1. And if this has 1, 0, my inverse has to have 0, 1. Okay, so over here I have 3, 6, 0, 6, 3, 1, and 0, 1. Okay, so we do in fact get that reflection across the y equals x. Okay, this is y equals x. Alright? That is inverse relations. Have fun!